Welcome to Inside Builder channel. Solopreneur's secret weapon. Developing microservices web app with agentic IDE like Cursor and Windsurf Codium. This is part 7C. Moving from modular to microservices. In this series of videos on microservices, we have been asking this question: can agentic IDEs build scalable web applications? And the answer has been resounding yes. Cursor-like agentic IDEs can build scalable applications. However, you have to understand what is scalable, what is the meaning of scalable, that is, and you also need to understand the 4 key software design principles, that is dependency injection, separation of concern, inversion of control, and open-closed principle. These principles are primarily required when you are going to do the horizontal scaling. In order to effectively do horizontal scaling and to avoid the challenges, the 12 challenges that we discussed in part 7A of this series of videos, you have to understand and use, in fact, implement all of these software principles in your applications and in your code. As we already know, we are not going to write the code, right? We are going to get the agentic IDEs like Cursor to write the code. So for that, we need to first of all understand that we need to get the overview of what are the components of a microservice. But before we dive into the core components of the microservice that you see here, we will take a look at a regular monolithic server. So if you look at a regular monolithic server, which is going to have these files, it's going to have a main, models, views, and authentication modules. These are all going to contain the respective details of the entry points, the routes, the database connections and setup, the views that process the logic, and the authentication process along with the dependencies. Now, when you are going into the microservices, then the layers of the application changes. So the layers becomes the API, the routing endpoints, the schemas where the data validation is done for the requests and the response. We have the services where the business logic is processed, and also the final data structures where the models are pushed into the database. Also, there is an intermediate layer called as a repo layer where the interaction between the services and the models are further abstracted to decouple it more. If you look at a monolithic server, the folder structure is pretty simple. But when you look at the microservices server, you will see that the folder structure is much more involved. You will see that the app to begin with has a main, and then there is going to be a core, routers, services, and repositories folders. Each of these things have different concerns to manage. The core will have the database and the authentication processes because these will be shared most of the time. And even if it is not going to be shared, then you will have multiple modules of databases that you are going to connect, but it will be under the core. You will have the router folders where the API calls or the API routes will be handled. You will have the services layer where the business logic will be implemented, and you will have the user repository layer where the interaction between the models, that is the tables inside the database, and the services are taken care by the user repositories. These kinds of knowledge and overview is one of the important steps for you to move towards microservices from the monolithic kind of a server. So before we dive into the discussion on this block diagram, I would like to show you the real code. Now here you see is a modular, almost a monolithic to microservices migrated server. This is still not a microservice. This is still at a modular level. Okay, I am actually showing you a modular level right now because microservices is just one step from this code. So you'll see that this is the main.py, which is having the varieties of routes to user as well as order router. Here you can see that, and it is having the connection to the databases, and the FastAPI server is starting from here. And after that you will see just these 2 routers. That's it. So where are the rest of the routes and how the server is working? So if you look at the folder structure here, you'll see that it has got the core, the repositories, the routers, the services, etc. And the main and the requirements are at the top level. This is the structure that we saw just now, right? This is the structure that we saw just now, right? And now knowing this structure is very important, because when you are going to let the agentic IDE to develop such an application for you, it is going to develop this folder structure by default. It's not going to ask to you to should I develop or not, because you are going to ask for a microservice, then it goes with the flow of the process. So it has already been taught how to create the microservices. It is already trained for this, and it will go ahead and do it for you. Once it does, you should know what it has done. So once it places all these folders and it is placing all the files under it, then you should know why these files are created and what are the purpose of these files, so that once you read those files, you'll be able to understand what the server is doing. So here we see that the database layer is connecting with the database. The authentication layer is getting the authentication setup, the authentication flow set up with the JWT tokens. And you can then move to the, it is under the core, that is under the core folder. If you go into the repositories, you can see that it is creating the tables inside the database, and this base is getting imported and inherited from the database module. You can see that here. And from there, it is also implementing the create order function, which is also getting used further. So you can see that the order repository is only concerned about the orders, and the user repository is concerned about the users. You can further break this into one more layer where the database tables are kept separate, but it's not required. Here it's a small server, so you're keeping it as it is, but you can further separate it also if you wish to do that as a database layer or the data structure layer. So you can further break it. After the repositories, you see the routers. Inside the router, you have the authentication router. So each of the module, the auth router takes care of the login process, the order router takes care of the order process, and each of these modules have their own input requests and output responses. So the data validation is taken care inside the routers itself. So now you must be seeing the overall picture that is forming around the decoupling process of the server, right? Once you run through this, I will show you a actual server which is monolithic. So you'll see the difference. So in case of user router, you will see the varieties of logic that is linked with the user. And when it comes to the order services, placing order and fetching order is taken care. And in case of user services, you see register user and authenticate user is taken care. And all of these functions are importing their dependent functions from the modules. So it is a completely modular and also at the same time decoupled form of working with the varieties of services. I'm not diving into individual parts of the code, because the code itself can be explained pretty easily with help of the agentic IDE. The point I want to make here is that if you guys are still new to microservices, and if you're thinking that how to learn, then just dive in and start learning. So it's one of the reason why I am creating this, and I'm even sharing this things with you guys. It is important that you start learning from the high level and then start diving in and code at a very high speed. Well, now you have seen the services, you have seen the routers, you have seen the repositories and the core. And then again, if you come to the main.py, you will see that it is just this app.include router and app.include router on order and user router. If you want to create a microservice of this particular server right now, all you need to do is create two servers basically, FastAPI servers that has this app.include, that will be user server, and there will be order server, which will be separate. So there will be two different servers. Okay, and both of these servers will be separately called, and it will be separately instantiated using separate commands, separate FastAPI run commands. So that is how the microservices are created. I am not showing that creation part here. I want you guys to explore it and try to run two different FastAPI servers, and I will discuss about how to do that in the next video. So I want you guys to get hands-on, get your hands dirty with this kind of a setup and try to run it. And once you get comfortable with running multiple servers, and then you can think about creating inter-service communication using REST API. Because think about it, we are having a user service which is registering and authenticating the user, and we have an order service which is fetching orders and placing orders, right? How will you make the user service to get the details of the orders? So it has to raise a request. It has to send a REST API request to the order server and then get the data and then update it in the user service. So it has to go through that process, and that process of inter-service communication also needs to be established. That is one of the important aspects of microservices. You don't need to use only REST API. You can use various other asynchronous messaging services also, where you don't create a REST API request, but you make or allow the asynchronous messaging services to update the database accordingly. So that is also possible. So there are a couple of ways around this, but I want you guys to first of all get used to this aspect of having a single server file, that is main API. You split it into two servers and then try to run them in separate commands and see what is output. You'll be it's not something that you need to be confused about. Once you do that, you will understand, okay, this is what individual servers look like, and then you can go to the next step of microservices. Okay, so we have seen the overall structure, and now let us go back. So we saw this entire structure, we compared it with the regular application, right? Now let us look at the components of a microservice. So we have a main entry point, and then we have a whole lot of common applications and services that we need to implement, like the dependency injection, the authentication, the testing and CI/CD pipelines, the configurations, the API gateways. Tell me, all these things are required if you are going to have a fully fledged software that is going to be serving a lot of users. Okay, it is better that you have all of these things. But when you're going to develop, when you're literally dipping your toes and trying to get the lay of the land of microservices, you can keep these things aside for a couple of more sessions. And once you are comfortable with the agentic IDEs, once you are comfortable with the code that is written by the agentic IDEs, then you can slowly bring in all these things one by one. It's actually important to keep the things simple. We discussed about the router layer, we saw the service layer, we saw the data access layer, and we saw the ORM layer. These are the various layers that we saw in the application itself. So you see the folder structure, the core router services repositories is actually aligned with the layers of the microservices also. So that is how the entire service are developed in the first place. So any developer who is trying to find out what is happening in the microservice, it becomes way more easier by following these kinds of this set of schemas, right? So understanding the schema, understanding the folder structure comes first. So once you understand the folder structure, then microservices are a walk in the park, literally. And second thing that you need to understand is this key software design principles. So if you're comfortable with these software design principles that I already covered in the earlier video 7b, you will be able to rock and roll immediately. Okay, now comes the important part. So this is where I got really surprised. So when you are going to create a microservice, there is almost 30 to 35 different Python packages, and similarly there will be Go packages, there will be Java packages, there will be JavaScript packages and libraries that help you to establish these microservices without much of a challenge. The point is that all these packages are kind of a framework that help you to automate most of these things. The various common grounds that we were discussing, the common services or applications, and then the various layers, all of these things can be done with varieties of packages and libraries. So here I am going to show, to begin with, the router layer. The main starting layer is controlled by the FastAPI like packages, and we need Pydantic for validating the data that is going in and coming out. In case of service layer, the business logic is purely Python. You will be working with Python if you are going to authenticate someone, if you are going to get some order processed, or if you are going to have a particular user connected with an order. All these things are service layer, and it is done through Python logic and various simple logic that you have learned in solving problems. Data access layer is where the ORM comes in. The database layer is where the driver of the database comes in. So access layer is more about the relational mappers and the database migration packages, while the database layer is more about the drivers that connect with the actual hardware part of the data. I mean, database is still software, but finally it's going to write the data to the hard disk, right? So that's why the driver part comes in. Then we have the authentication layer where the Python JOS and PyJWT comes into picture. We have FastAPI security also, which helps us in OAuth 2. Configuration management is one of the huge areas where YAML, JSON, and simple env files come into picture, and you can start manipulating the configuration from there. Dependency injection, again, as I told you, you need to understand how the dependency injection works, but FastAPI like frameworks already have a depends class and also frameworks that help you to manage the dependency injection. The inter-service communication can be done through MQs, message queues, gRPC, or HTTP requests. gRPC is becoming one of the go-to solutions for inter-service communication because you don't need to wrap the requests into a JSON format, serialize, deserialize, and do a lot of jumping around. You can simply use gRPC and directly connect with the other server. It takes a bit of a time to wrap around, but once you understand how the gRPC is working, it becomes way more easier for you to make the inter-service communication happen with less amount of overhead. Let's move forward. We have the logging and monitoring, starting with LogGuru. You have tracing. Tracing is one of the parts that I was extensively covering, not just in this microservices, in case of the artificial intelligence models also, OpenTelemetry related Phoenix server, the Arise server, and the Pydantic based the logger is also tracing related discussion that I had already covered. So do take a look at that if you have some questions on tracing. When it comes to metrics, Prometheus client is one of the go-to option that you have got right now. When error handling, with all these classes floating around, as we saw that the decoupling creates a lot more classes. If you go back to the server, you will see that every module. So if you go into the database, you will see it is actually sending some kind of a class. If you go into the order repository, you will see there is a kind of a class that is present. If you go into the routers, so there is again classes present. So API router classes. And if you go into the service, there is more classes, right? So, okay, in case of service, it's mainly the functions. Now, all of these classes are going to talk with each other, correct? And we need to understand how these classes are interacting with each other also. That's when you need to understand how to handle errors if the classes instance are going to throw it. So you need to know the stack trace of the entire, which class is creating the problem, which method is creating the problem. So FastAPI's exception handling is actually exceptional. So take a look at that and you'll understand what's going on. Pydantic is going to support you much more because you have a very streamlined way of requesting and getting the response back. So you'll know exactly what's going on. Object-oriented programming is the key here. When it comes to unit test, PyTest, and when it comes to API testing, we can use HTTPX, and mocking can be done with PyTest mock. CI/CD pipeline, we have various automations already available right inside VS Code and Cursor also. When it comes to containerization, we have Docker, and deployment is done through kubectl, that is Kubernetes, and console. So there are other applications that is present. And finally, we have the API gateway through Nginx, And also you can use the other kinds of gateway like Kong or proxy, NY proxy. And finally, when it comes to service discovery, console is one of the application that you can use, and also K8s support service discovery to a certain level. So now much of the things that we were discussing from the microservices part of it, the layer parts of it, is already converted into frameworks by variety of open source supporting community, and they have given it to us. Only thing is, you need to understand how these packages work. It's going to be overwhelming. I completely agree to this point, because there's a lot of things to learn, right? And moreover, think about the amount of changes that is going to come when you are going to create a server like this, microservices like this. So my advice when it comes to microservices is that start small. Okay, start with 2 services and try to play around with it, and try to implement the communication between these 2 services. Try to get them online and see how the deployment happens. There are varieties of free services like Railway app that you can use to deploy these microservices and see how they communicate with each other. And in the process, you can get familiarized with these various design principles, the software design principles that we are talking about. And once you see the data flowing between these software design principle based classes, then you will actually feel, not just learn, you will just feel how the data is flowing. Because now we have moved from literally learning and understanding to feeling how the software is working, right? That is possible because of the agentic IDEs. Let us go back. So we all started with this simple question, like, can we build scalable web applications? Yes, you can. As I showed you here, the entire application here, what you see, has been built with help of cursor. Okay, so it's not that you cannot build it. The question is whether you will understand after it is built. And this set of videos and the next video, where I will be wrapping this entire part, will help you to understand how this building can be done. And in order to build such microservices, you need to understand the concepts of the software design principles, and also work to learn about the basics of the microservices, the patterns that is involved in microservices, and the layers involved in the microservices. So I believe that this video has been helpful. Do subscribe to my channel for further updates on similar kind of videos. And also, if you have any questions and comments, do leave it in the comment section, so I will be able to give you some feedback on that. And with that said, I would like to leave this video with 4 words, that is practice, practice, explore, explore. See you guys.